Hey folks, it's Mr. Ray here. We're going to continue on with quadratics with a lesson where we're going to do something called completing the square. So let's talk about what that is. If you remember when we first looked at quadratic equations, we were given this equation, y equals ax squared plus bx plus c. So basically you're adding this x squared term to what looks like a linear equation from these two terms. And it's the x squared term that makes it quadratic. Okay, it says the values of b and c could be 0, but the value of a cannot be 0. Okay, so it could just be y equals 3x squared, or it could be y equals 3x squared plus 5x plus 1. Okay, so that form that we learned at the beginning is called standard form. Standard form is basically, it means there's no brackets. It's just a term plus a term plus a term, and that's usually the way we're given quadratic equations, is in that form. There's another form that we kind of created by using transformations. We stretched, compressed, reflected, and moved the parabola up and down, left and right, using these parameters a, h, and k. H and k. H moves the parabola left and right, k moves it up and down, and a does all sorts of things. It stretches, compresses, and reflects. So a changes the shape, h and k just move the shape around the graph. Okay, and the reason why we call it vertex form is because hk, if you put that as a point, hk is the vertex. And the vertex is probably the most important point on a parabola. Okay, now, if I gave you this equation, an equation in standard form, you have no idea where the vertex is unless you maybe graphed it using technology or a table of values. But there's a much better way of getting the vertex, and that's to change standard form equation into vertex form. And that's what this completing the square process does. Changes standard form of a quadratic equation into vertex form. Once that's done, we can pull out the vertex coordinates very, very easily. Okay, so I've got a step-by-step process here. It may not mean that much the first time we read it. Hopefully you'll get the first couple steps, or maybe the first and the last step, and we'll go through it. And after a couple examples, we'll come back and look at this again, and then it should make total sense. Hopefully you don't have to memorize this, that after a while you just know how to do it because you've done it several times. So again, practice, practice, practice. Don't memorize. Okay. So you can see there's only 5 steps, and the first one and the last step are really pretty basic stuff. It's the second and the third step that are the tough ones. Okay, so what we're going to do is we're going to put brackets around the first two terms, the x squared and the x term. Okay, if there happens to be a constant, we'll leave that outside the brackets. And then inside the brackets, we're going to factor out the coefficient of the x squared term from both the x squared and the x term. And then what we're going to do is, the second step is the completing the square process. So we're actually going to turn the expression inside the brackets into a perfect square trinomial. So if you remember, a perfect square trinomial is when you have x plus a number squared. Okay, that creates a trinomial. That when you factor it, we get basically a binomial times itself, and we call the trinomial a perfect square trinomial because when we factor it, we get the same binomial twice. So how do we do that? It's actually not that difficult most of the time. So what we do is we take this time we take the coefficient of the x term. Okay. So coefficient of the x term, we take half of that value. So if it was, say, a 6 plus 6, half of that's plus 3, and then we square it. So we get plus 9. Plus 9 is that magic third term that if we added it to the two terms in the brackets, make it into a perfect square trinomial. So not that difficult. Now, problem is we just can't arbitrarily add something to the equation. It's going to change what the graph looks like if we did that. So we have to actually not just add the term, we have to add and subtract the term, and then we have to take the subtracted term outside the brackets. And that's the third step here. So we'll look at that. And then the last part is really just simplifying. The fourth and fifth step are usually one step when we do completing the square. So let's try this out. And then after two examples, we'll come back and look at the steps again. Okay, so this one says rewrite y equals x squared plus 8x plus 5 into vertex form. And I give you a little template there to remind you what vertex form looks like. And I didn't say this was standard form, but hopefully you recognize you got an x squared term, an x term, and a constant, no brackets. That's standard form. We want to change it to vertex form. We're going to do that by completing the square. So the first step we do is we put the first two terms, the x squared and the x term, inside brackets. So no big deal there. No math required in this step. Okay, and then what we do, normally what we would do for the second step is if there's a number, a coefficient of x squared, we would factor it outside the brackets from both of these terms. Now in this case it's just x squared, so we don't have to do that. So we kind of skip that step. And now we go to the completing the square part. Okay, so I'm going to write the first two terms. And if you remember, we now focus in on the coefficient of the x term. We take half of that value, so that's positive 4. We square it, that becomes plus 16. And that's the 16. So that thing right there, that's a perfect square trinomial. Okay, now we can't just leave it that way because we've obviously changed the equation a lot. So I'm going to, inside the brackets, I'm going to put a minus 16 to kind of correct what we just did there. And you'll see how we clean that up in the next step. And the plus 5, still outside the brackets. So all we really did in this step is add 16, subtract 16, because 16 was the term that makes this a perfect square trinomial. Okay. So you might look at that and go, well, what's the point in that? That's just 0, and then you're back to where you started from. What we're going to do is take this outside the brackets, okay, and then combine it with whatever's already there. So I'm going to keep the first three terms inside the brackets, and the minus 16 comes out, so over there. Now I have to be careful. You'll see on the next examples, I can't always just take it outside the way it is. If there's a number that we factored out, say if that was a 2 up front there, we'd have to multiply it by 2 before we bring it outside. But in this case, there's nothing there, it's just a 1. So we just bring it out as is. Okay, and this is the last step. So what we do two things. We change this. This is our perfect square trinomial. We're going to change it into a binomial squared. Okay, and we're going to combine these two constants into 1. So adding those together, we get a minus 11. Okay, now how do we turn this into this? Okay, well, the first term is always going to be the variable you're using. So that's an x. Okay, so you can write that in pretty much without much thought. Now, the second part is kind of the, do you remember up here, in order to get to 16, we took half of the positive 8 and then squared it? Okay, so to get what goes in here, we just take half of that. So we don't do the second part of squaring it. So half of positive 8 is positive 4. And we're done. Okay. Now, if you expanded this, if you wanted to change, so this is now vertex form here. If I gave you the vertex form and asked you to create the standard form, you would just expand this. We did that in the last unit. And this actually turns into this. Okay, and you'll see that going backwards, we're going to end up where we started from. Okay, so there's our first completing the square. How would you know if you're right? Well, you could put both of these equations into Desmos separately, and if you get the exact same parabola showing up, exact same graph, every point is on both, and it can't just be close, it's got to be exact. If they're exactly the same parabola, you know that you did correctly. Okay? If they asked us to find the vertex, we would take it from the h and k parameters. So if they did ask, we'd say the vertex is -4, -11, because remember it's x minus h. So what would h have to be for it to be x plus 4? It would have to be, h would have to be -4. Okay, but they didn't ask us, so we'll just leave it like that. Okay, let's try this one. Okay, so this time we got a 2x squared plus 12x plus 11. First step, put the first two terms inside brackets. And the constant goes outside. And now we actually do the second step, or it's actually part of the first step. But since there's a 2 as a coefficient, we're going to factor that 2 out. Okay, and you'll always have an x squared here when you factor it out because you're always factoring by that number. Don't forget, since we're factoring the 2 out of this expression in the brackets, we have to factor it out of the other term too. So it's like dividing by 2, so that's a plus 6x. And you can always check by expanding, right? If you multiply this back, you would get that. Okay, at plus 11, still there. Okay, now if you get once you practice this a fair bit, you could go directly to this, but it's always good to be safer than you have to be, because you're not going to make silly mistakes, hopefully. So either way, if you did this in 2 steps, just brackets and then factor, or brackets and factor at the same time, either way is good, as long as you get the right answer, of course. Okay, now we go to the next step. So the next step is find that magical third term that makes this a perfect square trinomial. And then we're going to add and subtract it inside the brackets. Okay, so remember how we do that? We take half of the coefficient, so it'll be positive 3, square it, we get plus 9. Okay, and then we immediately correct it. Put a minus 9, so basically this is the exact same as above, except we know what number we need to make it a perfect square trinomial. Now what we're going to do is get rid, I always call this taking out the garbage. So we want to take the -9 outside the brackets, but this time there was a factor outside the brackets. So this number here, -9, is really the number -18. So if I bring it outside, I have to bring it out as -18 or -18. So that's what I'll do. Everything else is the same. Plus 11 and then the -18. Okay, and then the last step, we're going to do 2 things. First thing, we're going to change, this is our perfect square trinomial that we created. I'm going to change that into a binomial squared, and we're going to combine these 2 together. So this turns into that, and this turns into -7. And remember, first term is always the variable, and then the second term is half of the coefficient of the x term, so that's a plus 3. And if you don't believe or you want to check, again, just expand this. You'll see that x plus 3 times x plus 3 is equal to this. And a lot of students will ask me, well, where did the x squared go? Well, the x squared's still here. It's just been factored into this binomial. Okay. All right. So that's the vertex form. But they asked us, what did they ask us? Find the vertex. So we're not quite done. So we'll say the vertex is equal to, and I want always you to put it in into coordinate form. So brackets with a comma to show that it's actually a point. And remember, the x coordinate of the vertex comes from here, but it's the opposite sign because it's x minus h. So it's -3, and then this is -7 as is. So that time we got the vertex. Okay, so that's our second example. I promised you guys we go back to the steps. Hopefully now they make a little bit more sense. So first step, group the first two terms and factor out the coefficient of x squared. And again, I was doing this in 2 steps. You could do it in 1. It's up to you. The second step, most important step. So inside the brackets, you want to make it a perfect square trinomial. So you add and subtract. Well, I'll start over here. You take half the value of the coefficient of the x term, and then you square that, and then you add and subtract that value inside the brackets. Okay? And notice whenever you square a number, you always get a positive. So you're always adding and subtracting in a positive value. Then the next step, the taking out the garbage step, move the subtracted term, the one that you put in there to kind of temporarily correct adding the term you really want. Move the subtracted term outside the brackets, make sure to multiply by any factor outside the brackets like we had to do with the 2 in the last example. So we had just a reminder of what that was. In order to take the minus 9 outside, we first had to multiply it by the 2, and then it became a minus 18 outside the brackets. So that's what that means. Simplify the constants outside the brackets. That's probably second easiest step of this. Just add these two numbers together. And then the last part was turning that perfect square trinomial into binomial squared. So it's always x plus or minus a number squared, and that number will be half of the coefficient of x. Okay? So hopefully that makes some sense now. So if we go to the last 2 examples, we got examples 3 and 4. Convert the quadratic equation, and this time you notice we've only got 2 terms. Doesn't matter. Still going to do the same process. So first step we do, and this might seem a little bit ridiculous, we're going to put this inside brackets. And this time there's nothing outside the brackets because there's no constant term. So you could just do the first and second step together. So now we're going to factor out the negative 4. When you do that, you always get x squared as your first term. And don't forget to factor out a negative 4 from here. It's like dividing it by negative 4, so that's going to be minus 2x. Okay, and nothing outside there still. So now we're going to complete the square inside. So I've got x squared minus 2x. So what number do I need to complete the square? Half of that number squared. So half of that number is negative 1. Negative 1 squared is positive 1. So we add 1 and subtract 1. Okay, and now we take the garbage out. We want to take the minus 1 outside the brackets. And this time, just like the previous example, there is a factor outside the brackets, so we have to multiply what we're taking out by that factor. So negative 4 times negative 1 becomes a plus 4. Okay, so the sign can change even though you're taking it out, taking a negative number out. Sometimes it turns into a positive number because of the multiplication. Okay, now the last step, now we don't have to combine 2 numbers here because we really only have the 1, so that's already done. So all we do is we turn the perfect square trinomial into a binomial squared. So it's always, you always know it looks like this, and then the only question is what number do I put there? Well, that number is going to be half of the coefficient of x, so that's going to be minus 1. And that's vertex form. So vertex form. If the question asks what's the vertex would be 1, 4, the point 1, 4. Positive 1, positive 4. Okay, now you may be thinking, oh, this seems really nice. We haven't had to work with any decimals or fractions. Well, that's not always going to be the case, so I put in an example here to show you that it can be more difficult, but the steps are the same, but sometimes the math is a little bit trickier. So let's do this one here. So find the vertex of the parabola with this equation. Is the vertex a minimum or maximum? Okay, so So since we're trying to find the vertex and we have the equation in standard form, that means we're going to complete the square, turn it into vertex form, and grab the vertex from our h and k parameters. And then we'll answer this question at the end about a min or a max. So first step, put brackets around the first two terms. Okay, oops, I guess I overshot that one. So brackets go just around the x squared in the x term, and the minus 1 comes outside. Okay, next step is we factor out the negative 3. So negative 3x squared. Now this time it's not so nice because negative 3 doesn't go into 7 very nicely. So I'm going to have to leave as a fraction. So basically 7 divided by negative 3 is negative 7/3. Okay. Now, I always get asked the question, can I write that as a decimal? I don't like working with fractions. Well, sometimes you can and sometimes you can't. Okay. If you type that into a calculator, 7 divided by 3, you're going to get basically a calculator filled with 3's. Basically, it's going to be 2.333 forever. So definitely that you cannot change to a decimal. But if you had, say, 7/2, 7/2 is the same as 3.5 exactly. So you can convert to decimal if it's exactly the same value. And you can't round, you can't chop off digits. Okay, so we're leaving that as a minus 7/3 x. The minus 1's still there. Okay, and now it's going to get a little bit trickier completing the square because we're going to be doing some math with the negative 7/3. Okay, so the first thing we do to get that third term, we take half of that value. Okay, so think of when you say half of, it's the same as multiplying by 1/2. Okay, so if I multiplied negative 7/3 times 1/2, I get negative 7, you're multiplying across, negative 7/6. Okay, so that's half of that value, but now we square that value. So when I square that, so negative 7/6, that's the same as negative 7 squared over 6 squared, which is 49 over 36. And I can't reduce that. So that's what I'm going to add and subtract, because that's the magic third term. So that's plus 49/36 minus 49/36 minus, and then the minus 1 outside. Okay, so the step we're going to do now is take the garbage out. We want to take that outside the brackets. Okay, so let's just put the first 3 terms inside the brackets, unchanged, bracket. And now we have to figure out, well, I'll put the minus 1 here, and then, so I have to multiply this negative 49/36 by negative 3. So it's not that hard if you just remember how to multiply fractions and fractions with integers. So we're taking that negative 49/36, we're multiplying by negative 3. Negative 3 is the same as negative 3 over 1. Okay, now I could multiply across the top, but I'm going to get some big numbers. I can actually reduce first. The 36 and the negative 3, I can divide both by 3. So I get 12 here, and I get negative 1 here. And now when I multiply across, I get negative 49 times negative 1, which is positive 49, and 12 times 1 is 12. Okay, so that's the number. When I move this outside, that's what I put. And notice that it's plus 49/12, right? Because that number we multiplied, both the numbers we're multiplying were negative, so it becomes positive, just like the last example. Okay, so that's a little bit messy, but you just have to be careful with your math. Make sure you know how to work with fractions. Okay, so now I'm just going to okay, now, so I'll leave that for now, even though we could do that at this point. We're adding an integer with a fraction, so I'm going to do that over here. So remember, so the negative 1 is the same as, if I want to put that over 12, because I have to put it as a fraction over 12 so that I can combine the two numbers together. So negative 1 is the same as negative 12 over 12. Okay, and then we're going to add it to 49 twelfths. And now we can do it because the denominator is the same, so I get negative 12 plus 49, or 49 minus 12 is 37 twelfths. Okay, so that's what I get here. Can't reduce that, so I'll just leave it as it is. And we'll never put mixed fractions, okay? So if you're working with completing the square, I want you to leave your fractions, could be here, as improper fractions, okay? So now the last thing we do is just convert this into a binomial squared, and we've already done the last part there. So remember, it's x, and that number is going to be half of the coefficient. So half of negative 7/3, remember that's the same as negative 7/3 times 1/2. So that becomes minus 7/6. And we're done. So that's the vertex form. So that we can then state the vertex is, and now this is minus 7/6. So h is actually 7/6. So we'll just leave it like that. And then we have 37 twelfths as our k value. It goes there. And then the other question was, is the vertex a minimum or a maximum? So this has to do with whether the parabola opens up or opens down. And that's totally dependent on the value of a. So you notice the value of a in the standard form is the same as the a in the vertex form. That will never change. So if a is negative, that means the parabola is reflected. So it looks like that. So your vertex is actually a maximum. So I'll just tack that on here. The vertex is that and is a maximum. And I'll just put the reason is because a is negative, a is less than 0. If a had been positive, it would open up and the vertex would have been a minimum. Okay, so you've had 4 good examples there. 3 not so bad, and 1 a little bit trickier with fractions. I would say, most of the questions you're going to get, you won't have to work with fractions, but that's not always going to be true. You'll get a few questions that you'll have to handle the fractions. So got some homework questions down at the bottom. Again, make sure you get lots of practice doing this. It's not that tough of a process. It will always work, unlike factoring, which factoring is more difficult because it doesn't always work, and you have to figure out which process to use to factor. Whereas completing the square, it always works, and it's always the same process, always the same steps. Okay, so hope you found that entertaining. Maybe not entertaining, but at least informative. And we'll see you on the next lesson. Have a good day.